Hello everyone, welcome to MindSpan Education. So in last few videos we are talking about the independence of random variable, and in last video we talked about the what happens to expectations when we have the independence. In this video we will be talking about what happens to the variances when we have the independence. We have already knowledge about this variances and we have gone through the various properties of these variances. And if you have no idea about what is variance, I would recommend to go and watch my previous lectures. Then you will have a good idea about this variance. So what are the properties that we have already seen? Let's say if we have this random variable x, and this random variable x is getting scaled by some constant a, and if we want to find the variance of this ax, then that would be equal to a square times the variance of random variable x. This is the first property regarding this variance, and the second property we have seen that let's say if we have some random variable x and we are adding some constant to it, then the variance would be simply the variance of this random variable x. These properties are always true. Now coming to, you must have seen that there are many situations where we are adding the random variables, right? So I think that would be interesting to see the variance when we add those random variables. So what happens to the variance of the sum of the random variables? So let's say if we have these two random variables x plus y, these two are random variable and we are adding this random variable, what happens to the variance of the sum of these two random variable? We have seen in case of the expectation that the expectation of this sum of the random variable is simply the expectation of individual sum, right? But in case of the variance it is not simple, and in general this is not equal to the variance of individual sum of the individual variance of this random variable x and y, right? But if we consider, or if we assume, or if let's say if we have this info that this random variable x and y, these two random variables are independent, and the expectation of the, or the mean of the random variable x and y individually is 0, then we have this relation that if x and y are independent and let's say the mean of this random variable x is 0, as well as the mean of this random variable y is also 0, then in that case we can say the variance of this sum of the random variable x plus y, that would be the sum of the individual variance of these random variable, right? So this is a special case, but in general we cannot say, like in case of the expectation, that the sum of the expectation, sum of the random variance expectations would be the sum of individual expectation, right? We cannot say in case of the variance that the variance of the sum of these random variables would be the variance of individual random variables, right? But we can have this relation in case of a special case where these two random variables are these two random variables are independent and their expectation or the mean is 0, then this relation will be true. We can verify this relation. Let's do that. So what we want to do, we want to find the variance of this random variable x plus y. We know from the variance of definition of the variance of random variable, it is nothing but the distance, square distance from the mean, right? So in this case right now the random variable x is x plus y, and since the mean is 0, or you can think like this, so the random variable is this one, and we want to find the difference. So let's say the mean of this random variable x plus y, that would be this, right? And we have already assumed that the individual expectation or mean is 0. So overall this variance will be x plus y square, right? Here it will be by definition of the variance we have that it is nothing, variance is nothing but the square distance from the mean, right? So mean will be overall 0 for this random variable x plus y, right? So that would be simply x plus y square, right? And we can expand further, that will be x square plus y square plus 2 xy, right? We can use the linearity property, that will be the expectation of individual, right? So that would be 2 times expectation of this random variable x and y. And what is this? This is the variance of x, random variable x, because we have already assumed that the expected value or the mean is 0, right? So this is nothing but the variance of x. Similarly, what is this? This is nothing but the variance of y. And what will be this term? So these two random variables are independent, right? So we have in last video we have seen we can write like this, that would be expectation of random variable x times expectation of random variable y, and this will already we have assumed that mean is 0, so overall this term will be 0, right? So this is what we can say when we have this random variable x and y, those are independent and their mean is 0, then the sum, then if we want to find the variance of sum of these random variable, that would be equal to the sum of individual variance. Let's look at few of the example. Let's say if random variable x is equal to this random variable y, what will be the variance of x plus y? If you observe this case, what we are saying is that this random variable x is equal to y. So this is not the case of independence. Here we have dependency. If you know the x, you know the y, right? So these two random variables are dependent, right? But if you try to find the variance of this, right, so then that will be equal to the variance of 2 times this random variable x. You can make use of this property, that will be always true, right? So that will be 4 times the variance of random variable x. Let's take another example. Let's say if x is equals to, random variable x is equals to minus times of y, then what will be the variance of this random variable x plus y, right? So again this is the case of dependence, right? Because if you know the x, you know the y. If you know the x, then y will be negative times of x, right? So these two random variables are dependent. So here it will be nothing but the variance of constant, and again the variance of constant will be the constant and it will be 0. So if you see that here the key point to observe is that even if you know the individual expectation, or sorry, individual variance of these random variable, it is not sufficient to find the variance of the sum of this random variable. Why? Because you will have to know also that how these random variables are related to each other. In this case, how these random variables are interrelated, depending on that we have this variance, and how these random variables are interrelated, we have this variance, right? So it is, so even if you know the individual variances of each random variable, it will be not sufficient to find the variance of the sum. At the end you will have to also the information about that how these random variables are related to each other. Let's take one more example. Let's say if we want to find the variance of, or let's say if this random variable x and y are independent, and we want to find the variance of this random variable x minus 3y, right? And we know that this random variable, these two random variables are independent, so we can easily make use of this property, right? So that would be equal to the sum of their individual variances, right? And this will be equal to variance of this random variable x plus 9 times the variance of random variable y. Let's now use the property of these variances and try to find the variance of the binomial random variable. When we were discussing about the expectation, we have also find the expectation of binomial random variable. Now we will use the property of variance and we will try to find the variance of this binomial random variable. I hope you are aware that what kind of experiment we deal with. So let me recall you, we deal with kind of experiment where we do n number of independent trials, and this p is a probability of getting the success. With this kind of experiment we define a random variable x, and this random variable x is the number of success in an independent trials. I hope you are very well aware with this binomial random variable. Now we want to find the variance of this binomial random variable. Again we can little bit clever, and we can define another random variable, that is xi, and it takes the value 1 if the ith trial is success, and this same random variable xi takes the value 0 if we can directly write otherwise, right? So if we do not have the success, it takes the value 0. This is another random variable, and we have defined another random variable, this xi. This x is a random variable that is the total number of success in an independent trials, number of successes in an independent trial, right? So we can simply write this x as a sum of these random variable, like how we have done in case of finding the expectation of the binomial random variable. Same thing we are doing that, right? So again this random variable will depending upon how many ones we have got in an independent trials, right? Now we can easily find the variance of this random variable x, that would be equal to variance of the sum of these random variables. One important point to note here is that so these random variables, that xi, that is x1 or x2 or xn, these random variables are independent, right? So here that would be variance of this random variable x1 plus dot 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 variance of this random variable xn, right? And what are these random variables? It is either taking the value 1 or 0, so kind of Bernoulli random variable. And we know the variance of the Bernoulli random variable if p is probability of 1, right? So the variance of this Bernoulli random variable is p times 1 minus p dot dot dot. We have such kind of n terms, right? So that would be equal to n times p into 1 minus p. So this is the variance of this binomial random variable.